would like to tell you about how this simulation process is done. So whenever we are going for motor development, first we will have an analytical model right with us. The analytical model is there. Then we will go and set up FEA. So what is FEA feature? So Finite Element Analysis. It is a method, the FEM method, which divides a larger object into small and smaller objects, and the calculations is performed on each and every part of that finite element. Finally, it will be integrated to make an overall object. So by this process, we may get accurate results, which practically if we have any prototype model, the results will be practically matched with the simulator model. So whatever the electromagnetic tools from the Ansys, the Maxwell, which we have shown, it is a pure FEA solver. So the motor which we have done simulated in FEA, it is 95% accurate with the practical validation. So if we have any analytical model that can be done in the FEA analysis, we can perform an FEA analysis. Once we do the FEA analysis, we can do the multiphysics analysis. So previously, we thought motors are only a single physics, that is electromagnetic application, but it is not. It is a multiphysics application. We need to check the thermal aspects of the motor. We need to check the structural aspects of the motor. We need to see the NVH analysis. Noise, vibration, harness analysis. So in order to do this, all the major source is from the electromagnetic performance. Only in order to get the thermal analysis, we need to give the power losses, the losses in the coil, which are the sources to raise in temperature for the thermal aspects. Next, the centrifugal forces on the magnets or rotor, which causes the deformation, structural vibrations, harmonics for the structural aspects. So these all thermal and structural analysis. The major source is from the electromagnetic analysis. So these all simulations can be done inside the simulation. Tools we can couple with the different tools. So once you do the FE analysis inside the Maxwell, you can transfer the losses, electromagnetic losses, to the thermal CFD analysis, computational fluid dynamics, where you can check the temperature's cooling effects. What are the cooling effects we can apply in order to reduce the temperatures? So again, we can give the closer feedback, this thermal temperature distributions, to the motor electromagnetic analysis. And finally, because of this temperatures, there is an effect in the resistance of the coils, right? So again, the coil resistance may change. So by changing that, what are the difference in the electromagnetic analysis? So that feedback can be taken. Next, the forces from the electromagnetic analysis are transferred to the structural. We will do the structural analysis, the deformations. Then we can also check the noise vibration analysis. What are the vibration sounds we are getting? So these are performed in the different tools, and we can integrate and make a final product such that it is ready to prototype, ready to manufacture model inside the simulation.